Teacher Rishi.
Yes, good morning. Audible. Section A. Yeah, fine. Implementation of a linked list. Till last class, we have done with the implementation of linked list, and one assessment was there in the by God. I think hope everyone has completed that assessment. A simple coding part. And today we will go with the additional operations that what we can perform on the lists. Additional list operations. One simple function is that here a C function to find length of a single linked list. The total length of the list, whatever that you have created, that length of single linked list that we need to find. So there is one list operation and another operation searching a key element from the linked list. Okay. The additional operations, one is finding the length of a single linked list and another one is searching an element in a linked list. So a length, a simple code node is of a type struct and head we have taken here. What is this connectivity that created here in the list? What connectivity? Consider a list. A single linked list will have each node contains what? Each node contains in a single linked list what it contains. A single linked list, what each node contains. Link and the data, right? So the data field and the link field, how it is connected to each other through how the list is connected. What it can. First node contains the address of second node. Yes. Then the node which contains the address of next node through what? Link. It's pointers. Yes. Something and all people are typing it. Pointers and so on. Okay, fine. So here node, that current link of that node has to be established and total count initialized it to a 0. Initially we need to count the total number of nodes in the list. There is a length of that single linked list. We'll check with the first null. If it is not, if it is not, can see here, assign the current value to the first. The first link is assigned to the current. So 3 nodes in the list. Consider there are 3 nodes in the list connected. Last node connected to the null, right? So while current not equal to null, current is assigned to that first link of what we have here. F, the first, we have assigned it to a current link. So this act as a current link now. So while current not equal to null, so we're going to increment count plus plus. So now count plus plus, that is 0 plus plus, will become 1 in the first iteration. So this is a current, this is a current. When it is not null, when the current is not null, increment the count value, that is C plus plus. So initial count will be incremented by 1. After performing an increment operation, we need to connect it to the next link over there. What is the next link present there? So current is equal to current link. So we're going to assign it to this link. Then perform while again. So is current not equal to null? Yes. Increment the count value. The count value will be 2. So next again rotate it. Is current equal to null? Not equal to null? Yes. So list is 3. So the total count of the list will be 3. So the total length of list. So at the last iteration, the current will going link will be indicated to null. So in that situation, it will come out of this looping construct and returns the count value. Okay. So after performing counting all this, checking the link, the current will be in this position. After displaying the value 3, that current will be equivalent to a null value in that concerned list. So when it reaches to the null, so that consent count will be displayed. The current iteration count, whatever that is present or there, that data will be displayed. Okay. So this is how we calculate the length of a list. Is it clear? How to check the length of, so like a simple method like calculating a string length. So earlier str length function we were using for calculating a string length. Here a simple concept here that we need to concentrate here. The first node that we have to assign it to a current node. That current node link we need to check. If the current node link is not equal to null, increment the count value and establish the link of the current to the next. If not, when it is equivalent to null, so return the count value. So at current situation, whatever that count value you have got here, 3 nodes we have created, that concerned length of that concerned list will be displayed. Okay, is it clear? Length of, how to calculate a length of list, cleared or not? Yes, fine. Yes, good. So Next, after explaining this concept, I will explain about the internals concept. I think hope the mail is received for you people. A timetable and all. As you received it, internal timetable. Yes, fine. So go through the timetable. The questions will be a 12 questions. That is assignment. 12 questions will be there that you have to study completely all the 12 questions. In that, I'm going to ask any five questions. Any five questions in a continuously you should write and submit it. That is submission link guidelines and all I have provided. Please adhere to that guidelines strictly. Okay. Anyone having a login issues in the ByGuard, get it resolved well in advance. Okay. Hope everyone is having a login properly. One or two I received messages there was a login issue. Please resolve that issue as early as possible. Okay. Fine. The next concept is C function. C function to search for a particular element in single linked list. A simple C function, which is created to search a particular element in single linked list. These are all the additional concepts that they're going to ask it in examination as well as for your placement related things. So singly linked list, how and all we can use it. So this is one part that a single linked list, a simple C function we are going to create to search an element in the list. So let us consider one simple list here. Let me create a list first. List of data. Yes, a simple list we have created now here with the data elements of 10, 20, and 30. Right now, search is a function created here. Void search. You can see here void search, a function created with two parameters. One is a key that what we need to search that concern element in the list and the head node created. So as usual, this we will going to check the whether list is empty or not. We will going to check whether list is empty or not. For that purpose, one node variable is created through that if the head of the list is equal to null, if the head is equal to null, empty list is like a underflow condition of a list will be displayed. If the head is equal to null, we're going to print a empty list there. Okay. If not, next statement what we have here, assign that first node to the current node. So this is assigned it as current CUR. So this first node will be assigned it as current. Okay, so when current not equal to null, that is while current is not equal to null, when this is not equal to null, while this is not equal to null, check that if current data is equal to key, consider a key element is equal to 20. Consider a key as 20. Consider key as 20. Now current data, current is pointing to the first node of the list. This is current. Current data is equal to key. Is the current data is equal to key? Reply fast. Check. Is current data is equal to key. Key is 20. Current data is equal to key. No, right? So what we should do there? If it is equal, we will break. If not, establish the link to the next node. Okay, if not, establish the link to the next node in the list. So current is equal to current link. So next it will go to the, it will point to this. Now current will be in this position. Now the current will be at this position, right? 20. Okay, now if current equal to null, unsuccessful search. If not, again rotate the loop, current not equal to null. So then again in the second iteration, is current data is equal to key. Iteration number 2, is the current data is equal to key. Yes. Now is the current data equal to key? Section B and C. No answer. When you perform a link is established to the next node, is the current data is equal to key. The current data is also 20, key is also 20. Both are equal. So when both are equal, we will going to break at that part, right? When both are equal, we will going to break at that part. Once it is broken, it will come out of the loop. So if the given key is 40, if the given key is 40, what will be the output? If the given key is 40, what we will get it as the output? List is containing 10, 20 and 30 only. When you give a key element as 40, after performing the complete search in the linked list, what will be the output? Unsuccessful search. Is it clear now how to establish the linked lists? Is it clear how to establish a linked list? Yeah, fine. Thank you. Just a minute, it is loading. Now, last class we discussed about inserting last class we have discussed about how to insert a node and delete a node from rear ends. So now we'll go with the deleting a node from front end of a given list. This is a simple function to delete a node from front linked queue. This is about deleting a node from front linked queue. So queue delete list and a pop-up element. Consider this is a list of 10, 20, right? So q is equal to front of I, initial of I, that will take item. If not temp, queue is empty. So when data is not there, default, when there is no nodes created in the queue linked, that is a linked queue, so that will be written as empty queue. That is the underflow condition of the queue, right? So if not, item is equal to temp data. So when the queue is not empty, so when a queue is empty, when there is no item, that is when there is no item, when not temp. So if not temp, that is a temporary variable is not assigned. Default, if nothing is there, default it will going to point it to a null if the temporary data, there is a node is not created. So front of I means when the temp is pointing to the first node of the list, and the temp is pointing to the first node that is in the queue, linked queue. So now this condition will not be satisfied. This condition will not be satisfied. Directly it will go to the item is equal to temp data. This will be deleted. Front of I is equal to temp link. Establish a link to the next node. After deleting those, establish a link to the next node of the list what we have created over there. So then free temp. Why this free temp we are going to use? Why that free temp is used here? That free temp is used to deallocate the memory that what we have established over there. That memory will be established for that. So that concerned memory will be removed when you are deleting from that free temp. We're going to use that item written, so that concerned item will be displayed whatever that is deleted from the queue. So this is about how we can delete it, data from the front end. Okay, it's clear, no? These are all very simple functions. Just a minute, please. Is fine. Next part is the multiple queue implementation. how we can implement multiple queues there. So here are simple methods we are creating here. Function, you can see here, as it build functions here, maximum queues of 10, a simple structure, queue structure with a one link created for that queue. Okay, QP is a type definition structure. Initial condition, we need to check with the null condition. If it is null, a empty queue we need to check. This is a boundary checking. So queue checking has to be done here. So once this is checked, if the queue is not empty, if that queue is not empty, then we can create one function there to add an array of linked queue. Adding element at array of a linked queues. So how we can add that? So you can see a simple function written for there. Add item, add function we are creating here with an index as well as an item is taken into consideration. So what does this statement indicate? As I explained many times, what is the statement called? What is that statement highlighted here? Yes, fast reply. Majority, I will give little bit of break. Once I give little break, you people will go sleep. Huh? Instead of continuous explanation, I thought of giving a small break in between. Yeah, dynamic allocation. Good. So that we call it as dynamically allocating a memory. So dynamically we allocate a memory. Then after allocating this, star temp is a queue variable, linked variable created for that. So structure variable temp data is equal to item. So this will act as a temp data item if temp link is equal to null. So then we need to connect it to the next link over that. Okay, if not, check with that rare of I link is equal to temp. So establish a connection to the next links, whatever that we are the linked list. Here the main agenda of this function is inserting a data through the rear end of the list. So till now we have learned about front end of the list. So now we need to do it through rear end. So while doing it through a rear end, a link established should be through rear end. So for that we have created one temporary structure variable of type pointer. So after taking that, a memory is allocated. Once that memory is allocated, or a data item is stored, that whatever the value you want, that need to be stored over that. So if front of I, then the rear link is created to the temp. So once that variable is created, that's a link is established, that front of I, that what are the temporary variable what we are creating here, that need to be assigned a temporary to both front and the rear end of the list. So this is about how that inserting the data to the through the rear end of the linked list through queues. So that is done through queues. Okay. So everything which is with respect to the stacks and queues only, the linked lists, we need to create it. Okay. So till now we learned with the queues. Now we should see with the linked stacks. What do you mean by this linked stack? Inserting a node into a inserting a new node to a linked stack. How we can insert a node into a linked stack? So stack is the last in first out data structure, as we know that. Add an item to the ith level of the stack. SP stack pointer. We are creating one temporary pointer. Allocate the memory for that pointer. Establish the link and store that item and assign it to the top of the list. So it should be done through a single end only. Function call for the above push is a simple brief description I have given. Since stack always performs insert at the last position, new node temp is created. First new node temp will be created. Item placed at the data field of temp top is assigned. So the top is assigned to the temp link. So then variable top is changed to point to the temp. That variable top value that what we have, that will going to point it to the temp here. You can see that variable this point it to the top. So So this is how a stack operation that can be performed on the linked list. Just go through with this. Similarly, we will be having a pop operation. So delete linked list. Delete operation through stacks. So it's the linked operations that what we are learning here. So to delete an element in the stack, normally we'll use a pop operation. So check with the empty stack, underflow condition. If there is no elements, we're going to print it as a empty stack over there. If there is no elements in the stack, that is a list. There is if there is no any element present inside the list, we're going to print it as empty stack. If not, that item will be deleted with the establishing a link to the data. So that concerned item will be returned onto the output for displaying by removing the temporary link for that concerned linked list. So using stacks as well as using queues. So if you are familiar with both the stack and the queue operations, this is very easy to implement it in a linked lists. Is it cleared? Cleared or not? Reply fast. Just go through it once. I take the attendance by the time. Yes, answer the attendance. User number one. Answer your attendance: 1, 2, 3, 4, 5. Listen: 5, 6, 7,
Six
8,
present, sir.
9, 10,
Sir, two
11.
present.
Yes, ma. 12, 13, 14, 15, 16, 6. Adesh Sharma, it is taken. Don't put again and again. 17, 18, 1, 8, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90. It's not there. Okay, fine. So it's completed.
Sir, my message has reached you late. 62 present.
Enter the number again. Absentees, please enter fast. Okay, fine. Done. So the assignment, still many of you have not submitted in the ByGod link. Assignment 1, all the 12 questions, scanned copy with your USN number. Already the link is provided for you to submit it. So until unless you submit, I will not evaluate your answer script for the test. So write the complete assignment and submit it over there. Wherever the link is provided, it's a long back. I think it's 20 days before only the link is created. So assignment 1 link in the ByGod. Please submit the scanned copy with the file name of USN. And the internals, I think the guidelines has been provided. Any doubts is there, Thursday's class you can ask still any clarification regarding that internals. Now I will give one more question for the assessment. Be in the online. I'll take the attendance for the other section and I'll come back. Assessment question will be there. So please be online. Yes, you can leave the class and submit the assignment there. Complete the assignment and submit. Okay.